Hello, this is Research and Statistics Guide, and my name is Dr. Felix Ayodele Oyeleye. And just within the next few minutes, I want to share with you the concept of bivariates and multivariates. So let's get started. So I'm going to share my slide now just to discuss the concept. Just in a moment. Good. So today I'll be talking about bivariate and multivariate analysis in statistics. Again, it's important you understand how important statistics is even to your research journey. It's important you understand the basic terminology we use in statistics so that you will be able to effectively communicate the results of your research. So, to start with, every research starts from the fact that you study variables. And by definition, a variable is a characteristic or condition that can change or take different value. And most often in research, researchers are always involved in the work of trying to understand the relationship between variables. Maybe establish the connection between one variable or the other. Sometimes it could be in a group, and sometimes it could be across the population. You can have variables identified within a sample obtained from a population, and you may be studying certain important variables like gender and other demographic concepts even within a population. So, the entire individual that we usually study most often is referred to as the population. And like I said, that the researcher may be interested in the relationship between class size, which is one variable, and also academic performance, which is another variable, for a population of a third grade student. So essentially, we're studying the interaction between variables, how one variable affects the other. Now, another reality in population study is that many a times the researcher may not be able to work with the entire population, and hence he has to select a representative of that population to actually work with. Now, this representative that is usually selected using a specific technique is referred to as a sample. Now, a sample is selected to represent the population in the research just because we can't work many a times with the entire population. Now, the goal of doing this is to be able to use the results we generated from our research to answer specific questions about the population. Now, you can see that this schematic diagram talking about where the research itself starts from, or the population, and then you pick a sample. From the sample, you take it into your studies, and then the finding of your study, you generalize it back into the population. Now, there are different types of variables that we usually work with. Now, basically, we can categorize variables into two. We have the discrete variables and we have the continuous variables. The discrete variable consists of indivisible categories. They are usually absolute values, like number of students in a class, number of houses, number. More importantly, numbers that takes absolute value. They are referred to as discrete variables, okay? Now you can also have the continuous variable. Such variables are like time or weight, okay? And many a times you can have them in form of value that takes value can take place between two whole number. Like when you look at weights, weight can be, somebody weight can be 70.5, 70.6, 50.5. So the implication is that such kind of variables may not be absolute number. Okay, like in the case of time, you can have to the nearest minutes, to the nearest seconds, or half seconds. Good. Now, another important thing in research is that we also do what we call the measuring of variable. Now, the goal of doing this is to establish the relationship between variables, and then we measure the variables. Now, the process of measuring variable require set of categories called scale of measurement. Now, we can categorize this scale of measurement into four types. We have the nominal scale, we have the ordinal scale, we have the interval scale, and we have the ratio scale. Now, the nominal scale is usually on other set of categories, identified only by names. Now, for nominal scale, you can have example like 1, 2, 3, as we have the Roman figure here on the screen. Now, the only operation that can take place with nominal variable is just enumeration, because they are only identified by name. While the ordinal scale is an other set of categories, okay? You have them measured, they tell you the direction, or really don't tell you the difference between one individual and the next. You can have good, better, best. You can have greater, you can have less, but the actual amount between the greater and the less is not specified. Now, another example is the interval scale, like I've earlier mentioned. Now, in this case, it is an order series like the ordinal scale, but in this case, it has equal sizes of categories. Okay, so the interval measurement identify the direction and the magnitude of a difference. Now, the 0 point is located arbitrarily on the interval scale. Okay, and an example is our calendar date, the temperature on Fahrenheit scale, for example. Now, you can carry out operation like addition and subtraction on the interval scale, but not multiplication and division. Now, the last type of scale we'll be talking about is the ratio scale, which is an interval scale where a value of 0 indicates none of the variables. So the ratio scale identifies the direction and magnitude of differences, but allow ratio comparison, of course, but it could also, you can have operations like subtraction, multiplication, even being conducted on a ratio scale. An example is the age, the weight, the temperature in Kelvin. Now, in this case, there's no arbitrary 0 point. It means it starts from a particular place. You can't have somebody with minus 10 years, minus 50 kg. No. So it has a non-arbitrary 0 point. Unlike the interval scale, that the 0 point is arbitrary. It could take place at any point in your scaling. Okay, so after data collection, the usual thing we do is that we want to define our variables. Okay? And based on the type of variable, we choose the appropriate statistical analysis. Now, generally, depending on the number of variables we are looking at in our data sets, we can have it classified into three types: the univariate, the bivariate, and the multivariate. You can talk of univariate because you are dealing with a single variable. You can as well talk about of bivariate when you have two variables you are examining in your data set. And as well, you can look at a multivariate situation when you have two or more variables in consideration. Now, for the univariate analysis, the common thing is that if you have a categorical variable, the common operation you perform are the frequency and the percentage. But if you are dealing with continuous variables, then you may be able to do things like measure of central tendency, like your mean, median, and mode, or even the measure of dispersion. Very important. Now, for the bivariate analysis, you can talk of chi-square tests. You can as well talk of t-tests. If it is categorical, it will be chi-square test. If it's continuous, then you talk about the t-test. And of course, you can begin to look at correlational analysis, simple regression analysis. More importantly, if you are dealing with variables that you want to establish how they connect with one another. If it is just the relationship, it will be regression, it will be correlation analysis. But if you want to know, you want to establish specific quantification of how one variable exactly affects the other, then you'll be talking of regression analysis. Now, for multivariate analysis, an example, you can have the ANOVA test, the partial correlation. Partial correlation is a situation whereby you have more than two variables in discourse, while one has partial correlation with the other. In other words, it relates with other, but not necessarily fully. So you can also have the multiple and multivariate regression analysis under your multivariate analysis. So we have a typical picture of categorical variable in this particular table. And here we have the frequency and the percentage clearly outlined. And then here is an example of a univariate. The common thing that varies here is the SAT score, and then you have the frequency. Now, while the bivariate, you have the mark that varies, is a variable. The second variable is the age, that is bivariate. Now, while in the last example, you have so many factors outlined here, the intercept, the black race, the Hispanic race, and others. These are independent variables that are more than two, and then they vary even within this data set. And that makes it a multivariate analysis. I hope that is clear enough to give you insight into the different operation of bivariate and multivariate analysis and how variable is important even in our research journey. My name again is Felix Ayedele Oyeleye. I'll see you in the next video. Thank you.